Class, this is lesson 15, equivalent fractions and reducing fractions. Okay, so we've talked about this a little bit already, but please make sure this is in your notes. It's a good review for you to go through. So equivalent fractions are different fractions that name the same number. Okay, so here's an example. I have one shape here divided into two equal parts, and one shape of the same size divided into four equal parts. So I could shade in one of the two parts and have a fraction represented here of 1/2, or I could shade in that same amount on the shape divided into four equal parts, and I have now 2 out of 4. Okay, so these fractions, 1/2 and 2/4, those are equivalent. Those are equivalent fractions. They name the same number, but they are different, 1/2 and 2/4. Okay, the identity property of multiplication, which says that we multiply by 1 and get the same number, that's used to make equivalent fractions. So if we take the example up here, we'd have 1/2 times, and then this is where we need to have 1, and remember I was awful at writing these number 1s down, and then our answer is going to be 2/4. So what number do we represent as 1, so that when we multiply 2 by whatever we get 4, and 1 by some number we get 2? Well, this fraction then needs to be 2 2's. Okay, so remember that to change fractions to make a different equivalent form of that fraction, we're going to use the identity property, and we're going to multiply by a fraction that is equal to 1. Okay, so let's say we're asked to find an equivalent fraction to, let's say, 3/4 that has a denominator of 20. Okay, so that'll be a type of problem that you get. Write an equivalent fraction to 3/4 that has a denominator of 20, and this is exactly what I would do on my paper if it were me. I'd write the first fraction that they give us and the denominator that they want, and then I'd put an equal sign here, and I'd put a multiplication sign here, and then I'd write a fraction bar. And then I'd look at this and I'd figure out, well, what number do I have to take times 4 to get 20? Well, that's 5. So remember that this fraction needs to be 1. Okay, and since it needs to be 1, the numerator needs to be 5 as well. So 3 times 5 then is 15, and 4 times 5 is 20. So our equivalent fraction is 15/20. Now when you reduce fractions, your numerator and denominator can have a common factor of 1 only. Okay, so when we do that, when we reduce them, we write the fractions in lowest terms. Okay, so the numerator is a term, terms, 1s. Numerator is a term and denominator is a term, and we want them to be the lowest that they can be. So if we were to reduce, let's say 12/18, we need to figure out what factors 12 and 18 have in common. And so what you can do is you can list out the factor pairs. You can say 12 is 1 and 12, and 2 and 6, and 3 and 4. So that's 12. And then you can also say, well, 18 is 1 and 18, 2 and 9, and 3 and 6. And then determine which one of those is the largest one that they have in common. And I think if we look at this, we'd find it 6. So then we can divide both the numerator and the denominator by 6 to get our equivalent fraction. 12 divided by 6 is 2, and 18 divided by 6 is 3. Okay, so that is reduced because we know that 2 and 3 only have 1 as a factor in common. Now, another way that you could do this is if you look at 12 and 18 and you'd say, oh, well, I know that they're both divisible by 2. So you can divide them both by 2. And 12 divided by 2 is 6. And then 18 divided by 2 is 9. And then you need to look at this fraction, 6/9, and decide, is the only factor that 6 and 9 have in common, would that be 1? Well, hopefully you can realize that we have a 3 in common. And so 6 divided by 3 would be 2, and 9 divided by 3 is 3. And so we'll still get to the same place. We'll still get to the same reduced fraction. We just might have to do more than one step, and that's okay. It's all at what you see first. Ideally, you'll get the greatest common factor, and then you only have to do the step once. But if it takes you more than once, that's okay. Okay, so sometimes when we add or subtract fractions, we'll get mixed numbers, or we'll get fractions that need to be reduced. So, for instance, if we take 7/9 and subtract 1/9 from it, remember that we need the subtraction, we're dealing with fractions, so do we have common denominators? That's the first thing we need to ask. Yes, so I can subtract. Now remember, when you subtract or add, you do not change your denominator. So it's a 9, it's a 9, it needs to stay a 9. But 7 minus 1 is 6. And then, hey, look at that. It's the same fraction we were just dealing with in that second example. 6 and 9 have a factor in common, 3 and 3. So this will reduce to 2/3. Okay, so now we have to start questioning, is our answer in lowest terms, or is our answer reduced, or is our answer simplified? So you need to be looking for common factors. Also, if you have a improper fraction, 12/9, two different ways that you can go with this. One, you can reduce it first. So let's do a reduce first. Okay, if we reduce this first, we would say, well, let's see, they're both divisible by 3. And 12 divided by 3 is 4. And then 9 divided by 3 is 3. And then this is improper. So we need to divide it. So 3 goes into 4 how many times? 1. Subtract 3, we get 1 left, but remember that becomes our numerator of our remainder. So it becomes 1 and 1/3, and that's our answer. The other way that we can do this is to divide it first. Okay, so we're going to do this step first with the numbers 9 and 12. So we'd get 1. Subtract the 9, get a 3. That becomes your numerator, so 1 and 3/9. And then you have to check. This is a mixed number, but is the fraction reducible? Yes. They both have 3 as a factor, so I get 1. Remember, that whole number comes along, and 1/3. Okay, so there's two different ways that you can approach improper fractions. If you can reduce them first, and then divide, or you can divide first and then reduce. Either way. Now, if you're given a fraction like 80%, if you're given a percent and you're asked to change it into a reduced fraction, remember, percent means what? Percent means out of 100, so it's 80 out of 100, and then we're going to divide. I know that it's divisible by 10. So 10/10, and you may represent that as just crossing out that 0, but really what you're doing is dividing by 10. So that's 8 out of 10, and then 8 and 10 are both even, so I could divide by 2 2s and get 4/5, and that is 80% as a reduced fraction. Okay, I think that's all that we need to go over today. I know that some of you will struggle with reducing fractions. Just remember to go back to your divisibility rules and practice those. Okay? I will see you in class. Please bring questions to discuss. I know that you will have some. So be prepared to discuss questions. See you in class.